In this video, we're talking about a new concept called inverse right triangle ratios. So before we talk about just regular right triangle ratios, which were used to find the sides of a triangle, when we're talking about the inverse right triangle ratios, we're going to use those to find angle measures. So inverse means angle, regular right triangle ratios mean finding a side. Be sure you keep those separate because that's going to be critical later on. Alright, so in example 14, we want to evaluate the expression in both radians and degrees. And notice when I'm talking about inverse right triangle ratios, for instance, in example 14a, I see a little -1 up in the air. What that means is that's the inverse. So anytime you see that little -1 beside a right triangle ratio, we're finding an angle. So we're finding an angle measure. If you don't see that little -1, then we're finding a side measure. Okay, so be sure you keep those separate. Now, you do have a button for sine, inverse cosine, inverse tangent. It's pretty easy to get to. Let's do the first one. And we're going to start off in degrees first. We'll go and do all three in degrees, and then go back and do all three in radians. Okay? So for part A, we're going to do in degrees. My calculator's in degree mode. I'm doing inverse sine. So to get there, all you need to do is hit second sine, and you see the little -1 floating there. Now I'm going to type square root of 3 divided by 2. Now when you do square root in your calculator, you need to be sure to close that up before you do divided by 2. Otherwise, the calculator is going to think that the 2 is also underneath your square root symbol, which it's not. So be sure you do that one little piece there, otherwise you're going to get the wrong answer. So if I type it in correctly, I'm told that the angle that I'm working with is 60 degrees for part A. Let's do part B in degrees. So I'm doing the inverse cosine. So to get there, I'm saying second cosine of 2, enter, and it says error domain. Okay, so I'm just going to quit. Inverse cosine of 2 is an error on the calculator. I'm going to come back to that one in just a minute because it can be done. Even though the calculator doesn't like it, there's a reason why. We'll talk about it in just a minute. I'm going to go on to part C, talking about in degrees. So inverse tangent, so second tangent of -1 is -45 degrees. Okay. Now let's go back to part B real quick. So to solve this one, since my calculator gave me an error, I'm going to actually have to draw a sketch for part B. And essentially what this is telling me is that my radius, the radius of my circle is 2. So when I draw my circle or my angle in standard position, I'm going out to +2. And it's going to be at the point 2, 0. How do I know that? Because my radius was 2, and it's the square root of x squared plus y squared. Well, the only thing that's going to work, because I always start off on the positive x-axis, so that's how I knew 2, 0. I want to plug in 2 squared plus 0 squared and the square root of that. So I have the square root of 4, which is 2, so my radius is 2. That's the only point that's going to work, that's going to fit. Because cosine, remember, is x over your radius. X over your radius, and that's the only thing that's going to work. So my radius has to be 2. Now, your calculator is only set up, like I said in the previous video, your calculator is only set up to deal with radius 1. That's why the calculator wasn't happy when we tried to type this in. However, just paying attention to where this point is, I know that if I spun around and I'm at 2, 0, so I spun all the way around, then I have 360 degrees. Okay, so my angle is 360 degrees. Alright, let's go through and do radians now. Okay, so I need to change the mode of my calculator. My calculator is going slow. Or maybe it's my computer just in general. There we go. All right, so I'm in radian mode. I'm going to type in the first problem, so sine inverse of square root of 3 over 2. So second sine square root of 3, close it up, divided by 2. I'm in radian mode, and I get 1.05 for my radians. Okay, 1.05. All right. For the second one, cosine, it messed up with degrees. It might mess up again for radians. Let's check it out. So second cosine for 2, error domain. Okay, so calculator gives me an error again, so we're going to have to go back to our sketch for part B. No big deal. All right, and then part C, second tangent, -1. And I get -0.79, -0.79. All right, so let's go back to part B. We're talking about radians now. So I already saw before that in degrees it was 360 degrees. Well, I remember that when I had 360 degrees, I could convert it, excuse me, to radians. And that's just simply 2 pi. If you don't remember that conversion formula, remember it's just simply the angle you have, 360 divided by 180, and then times pi. The pi just comes along for the ride. So I'm going to say 360 divided by 180, that's 2. So I end up with 2 pi. Now, we did all of our other ones as decimals, so let's do 2 pi in our calculator. So 2 pi is 6.28. So I have approximately 6.28 radians. I have exactly 2 pi radians. So again, when you include the pi symbol, that's the exact answer. Here, I rounded, okay? So it's close, but not as close as it could be. And that's it for evaluating inverse trig ratios using the calculators. Let's do another example. So in this example, I have a triangle. I want to find the measure of the angle theta for the triangle that's shown. I have a right triangle, that's good. So what I'm going to do first, before I do anything else, is label my triangle hypotenuse, opposite, adjacent, just like we did in the earlier videos. The hypotenuse is always across from my 90-degree marker every time. And opposite and adjacent are based on where the angle theta lives. So here's theta, so that means the opposite is always across from it. And that means the third side must be the adjacent. So now I want to look at the pieces of information I'm given. I'm given adjacent and hypotenuse. Well, the only ratio I know that uses adjacent and hypotenuse is cosine. Okay, but I want to figure out what the angle is. So since I'm solving for angle, instead what I need to do is actually do the inverse cosine. So if you think about this as an equation, I'm going to plug in what I know. So I have cosine of theta equals the adjacent over hypotenuse. I want to get theta by itself too. So the only thing that will get rid of cosine is inverse cosine. So I need to do inverse cosine on both sides. I'm going to give myself a little bit more room. So inverse cosine on both sides. Alright, well, inverse cosine and cosine cancel each other out, so I'm just left with theta equals inverse cosine of 5 over 9. Now again, anytime I see that -1 symbol, I'm finding an angle measure, okay? Now, it doesn't tell me to do it in degrees or radians, so you get to pick. I'm going to do degrees, okay? I'm more comfortable with degrees. We've been doing degrees for a lot longer than we've been doing radians. So, I want to make sure I'm in degree mode, and then I want to type it in. So, second cosine of 5 over 9. And I get a decimal. Let's go 2 decimal places here just to round. So the angle theta is approximately 56.25 degrees. I like to fill in my picture. So as soon as I know this angle, I can also go ahead and find the other angle if I wanted to. What I would say is 180 minus 56.25, and I'm going to use my calculator. And actually, I forgot the minus 90 also, so don't forget that. That's important. That's my fault. Okay, so, but I did it in my calculator, and I get approximately 33.75. Okay, so I went ahead and found the other angle as well. The question in example 15 didn't ask for that, but I was like, hey, it's not too hard. Let's do it. And that's it for this video. Again, regular sine, cosine, tangent, regular right triangle ratios find sides, inverse cosine, inverse tangent, inverse sine. Those are used to find angles. Be sure you keep those separate. Let me know if you got questions.